This is Level 2, Video 4, where we will be looking at, in our book, Chapter 5, Section 4, the inverse and the contrapositive. Now we've gone a little off in the book here to Chapter 5 because the inverse and contrapositive are part of conditional statements, which we're currently studying. So again, a conditional statement is an if-then statement, and today we're going to look at the fact that any conditional statement can be reworded in one of four ways. There's the original statement. If a figure is a square, then it is a quadrilateral. This is a standard conditional statement. We've already studied the converse, where we flip the hypothesis and the conclusion. So we have, if a figure is a quadrilateral, then it is a square. In the original, the conclusion was quadrilateral. Now that is the hypothesis. There is a third type of conditional, which is called the inverse, and that's what we're going to look at next. The inverse is when we take the original statements, we have to go back to the original, and negate both parts. Negation is a big part of today's lesson. So, if a figure is not a square, if a figure is a square, if a figure is not a square. Negation is the opposite of. So the opposite of being a square is not a square. There should be nothing in between. It is something, it's not something. Then, it is not a quadrilateral. One mistake I see students make is they forget to negate both. Both the hypothesis and the conclusion are negated or made opposite of what they originally were. If a figure is not a square, then it is not a quadrilateral. The final conditional to look at is called the contrapositive. We have flipped them, we have negated them. The contrapositive is when we do both at the same time. We flip the hypothesis and conclusion, and we take the opposite of them. So, if a figure is a square, then it is quadrilateral, contrapositive. If a figure is not a quadrilateral, then it is not a square. These are the four different ways that we can look at this one conditional statement. It's also important to look at the truth value behind these statements. The original statement, if a figure is a square, then it is a quadrilateral. Quadrilateral meaning has four sides. Well, if something is a square, then it has four sides. This is true. We look at the converse. If a figure is a quadrilateral, then then it is a square. Translation. If it has four sides, then it's a square. Well, this is false. We have a counterexample to this. A trapezoid has four sides and is not a square. A kite has four sides and is not a square. Now what about the inverse? If a figure is not a square, trapezoid, then it's not a quadrilateral. Oh, but wait, yes it is. A trapezoid is not a square, and it's not and then it is a quadrilateral. So the inverse is false, and we have the exact same counterexample. Where we have to be careful is that a triangle is not a good counterexample. If a figure is a quadrilateral, triangle doesn't meet that condition. If a figure is not a square, well, triangle meets that condition, then it is not a quadrilateral. Unfortunately, it makes the conclusion true. It's not a quadrilateral. We are looking for something that meets the condition, trapezoid, and doesn't meet the conclusion. A figure is not a square, trapezoid, then it is not a quadrilateral. Well, yes it is. Finally, the contrapositive. If a figure is not a quadrilateral, okay, so it cannot have four sides, then it's not a square. Well, wait, this is true, because if it doesn't have four sides, then it can't be a square. Because if it was a square, it would be a quadrilateral. It turns out that the conditional statement and the contrapositive are always linked. No matter what, if the conditional statement is true, then the contrapositive will be true. If a converse is true, the inverse will be true. These two are also linked. If a converse is false, the inverse is false, and they will have the same counterexample. We need to understand the link between these. A conditional and contrapositive are always linked. The converse and inverse are always linked. Let's look at this some more. So, conditional and contrapositive will always have the same truth value. The converse and inverse have the same truth value as well. Statement. If an angle measures 90 degrees, then it is a right angle. True. If an angle is a right angle, then it measures 90 degrees. The converse is true. If an angle does not measure 90 degrees, then it is not a right angle. Well, if it doesn't measure 90 degrees, that would be measuring 70 degrees. It's not a right angle. If an angle is not a right angle, then it does not measure 90 degrees. All four of these statements are true. All that mattered was the original and converse were true, so therefore the inverse and contrapositive must also be true. If all four are true, we have a biconditional, which was caused just by the first two. An angle measures 90 degrees if and only if it is a right angle. We've seen this statement before. Okay, as we move on, we're going to take one more look at the conditional, converse, inverse, contrapositive, and how they are linked. So, here's our conditional statement. If it is snowing, then driving conditions are dangerous. We'll go with this to be presumed true. No arguing whether or not people think it's easy to drive in snow or not. It is definitely a fact that when it is snowing, driving conditions are more dangerous for anyone out there. Here's the converse. If the driving conditions are dangerous, then it is snowing. We should already be thinking about how this does not sound like it's true. Let's look at the inverse to confirm this. If it is not snowing, then driving conditions are not dangerous. Well, this isn't true. How about the contrapositive? If driving conditions are not dangerous, then it is not snowing. Well, that sounds a little bit like the first one. First of all, the first statement is true. If it's snowing, driving conditions are dangerous. Second one is false. It could be foggy. Foggy would be driving conditions are dangerous because we can't see. Well, it's not snowing though, so this is a false statement. If it is not snowing, could be foggy, then driving conditions are not dangerous. No, it's foggy. The driving conditions are dangerous. Again, the converse and the inverse have the exact same truth value, and they always have the exact same counterexample. Finally, if driving conditions are not dangerous, then it's not snowing. Because if it was snowing, the driving conditions would be dangerous. We have to be logical here. The contrapositive is linked. If the driving conditions aren't dangerous, we can guarantee it's not snowing. Because if it was snowing, the conditions would be dangerous. So, that is the inverse and the contrapositive. And the link between these is very important for the logical conclusions that we will be making in the next section. The final thing that we're going to take a look at today is because of this, we really need to start looking at making our own conclusions and where they come from. Some of the things we'll do in class after this lesson is we're going to start putting up statements like, if B is the midpoint of AC, what conclusion can be made? We can draw a picture and ask ourselves, if B is the midpoint of AC, what conclusion can be made? Well, then AB is congruent to BC. This is definitely true. Now, instead of going backwards, let's try to go forward with a new conclusion. What if we know that AB is congruent to BC? What if we just learned this, and now we're wondering, what else do we know? What does that mean? If AB is congruent to BC, we can make a conclusion. they're equal. They have equal length. Oh, well, if AB is congruent to BC, then if AB is 10, BC is 10. They have equal number value. Let's try another conclusion. If a triangle has two congruent sides. Now this is going to play to a vocabulary word that we haven't studied yet, but maybe you already know it. If a triangle has two congruent sides, do we know something that we've heard of before in the past? Well, conclusion. It's isosceles. Isosceles means a triangle that has at least two congruent sides. If it has two congruent sides, we can make a true conclusion. What about the last one? If AB is congruent to CD and CD is congruent to EF, let's think about the logic here. If AB is congruent to CD and CD is also congruent to EF, we can make the conclusion of AB is congruent to EF. So at this point now we're being given the conditions and we have to come up with the conclusions and go one step beyond that and say why. If B is the midpoint of AC, then AB is congruent to BC. Well, why? What have we studied? What do we know that allows us to make this conclusion? Well, most of the time, these conclusions come from some fact that we know. And one of the best facts that we can use is a definition. The definition of a midpoint tells us that if something is a midpoint, it divides into two congruent segments. If it's midpoint, then it divides into two congruent segments. That's the definition of a midpoint. So, if two segments are congruent, why is it that that means they have equal measure? What is that? What fact is that? What definition is that? The definition of congruence means that shapes that are congruent, shapes, congruent size, congruent shape, have the same length or size. So what do we think about this one? If a triangle has two congruent sides, then it's isosceles. Sounds a lot like this would be the definition of an isosceles triangle. Has two congruent sides. Now the last one on here is not a definition. There are more than just definitions that are facts. We can also have mathematical properties, or we could have a postulate. Even a theorem would be something that has been proven to be a fact. This has a special name of something we should have learned in algebra and will come about in video lesson number 6 as being major items for us to study. If AB is congruent to CD and CD is congruent to EF, our conclusion of AB is congruent to EF is justified by the transitive property. The next big step for this course is to start thinking about how we can make conclusions, and not just how we make them, but how we justify them. That concludes video lesson number 4 for level 2, the inverse and the contrapositive, and our first step toward making our conclusions and justifying them.